Okay, so this is a light box, and in that light box is a tube of gas. So there's nothing but hydrogen in this tube, and in the ends of this tube, which can be taken out, are metal on both sides, and that metal is connected to a device that's going to put lots and lots of volts of electricity through it, and going to give so much energy to the gas. The gas is going to get excited and will begin to glow. And because of the glowing, the specific colors of the light given off, and the analysis of that light, Bohr was able to determine the nature of electrons and how they behaved. So let's just turn on the light box for now. There it is, and you can see that nice glow. That's got that kind of pinkish, violet glow. And when I put a refraction grating in front of our camera, you'll notice a diffraction grating. Sorry, not refraction, diffraction grating. When I put it in front of my camera lens, things are happening. So let's turn out the lights and see if we can get a better view of what's going on with this light and the image that's being produced when I have this lens in front of the camera. I'm not going to get the room much darker than this, but when I put the lens in front of the camera, you'll note I get this image. And it's a starburst, so the image is repeated in all directions, but you will notice very clearly that off to the edges of the image, I have very clear and distinct lines of color. There is a darker blue-purple line, which is a little fainter. There's definitely a turquoise line, and then there is a red line. And the turquoise line then starts to repeat the pattern again as we go further away from the light. So I can kind of show that here. With the pattern. If I go off to the side, I might be able to see the pattern a little better. So I definitely see the red and the turquoise light, and it's a repeating pattern, and that dark purplish line is closer to the light source and fades as you get further from the source. That's why it's not as visible. But the point is that there are distinct lines of color of light. And those lines of color of light represent very specific amounts of energy. Because any wavelength of light or frequency of light has a very specific amount of energy. So this is a fingerprint. It's a fingerprint of the energy coming from that bulb. And different bulbs made of different atoms are going to give me different sets of fingerprints. They're going to give me different colors of light, meaning that they're going to be giving me different amounts of specific energy. And that told Niels Bohr a lot about how electrons behave around an atom, and that electrons have very specific energy while moving about in the electron cloud. So let's look at some other samples. This light is helium. So helium has not just one electron like hydrogen did, but two electrons. And when given energy and excited, those electrons get excited and give off specific light and specific energy. So again, I'm going to put the lens in front of the camera, and let's see what kind of lines we get here. Now, you can see we have different colors, different lines, and it seems to be many more than hydrogen. We definitely have like a turquoise line in there. We definitely have a kind of a purpley line. We definitely have that yellow-orange line. But those lines are much different than the colors given off by hydrogen. So this says that these helium electrons are doing different things than the hydrogen electrons. That's all I need you to know. I just need you to know that different elements have different sets of lines, which means different energies are given off when the electrons get excited. That means the electrons had to be in different places around the nucleus compared to previous or other atoms. The other thing that I need you to know is that these sets of lines are like fingerprints. So if I were to get another unknown sample and the unknown sample would give me these same kind of patterns of lines, I would know that that material is most likely made of helium. As a matter of fact, we can use this to analyze the light of stars from far, far away. We use a special telescope, we capture that light, and if we can find these different patterns of lines, we know what elements are, what the elements that the star is made up of. So I'm going to show you two more examples just for funsies, so we can see these different line spectra. So this is mercury vapor being excited and giving off this particular light. And mercury has 80 electrons, so you would expect that its line spectrum would be pretty complicated. But when I put the film in front of the lens, we'll notice that it's not terribly complicated. We have only a couple lines, although we definitely see that blue-green or that purple-green very close together, and we do see a red hidden in there somewhere. So it's simple in terms of structure because it really doesn't have that many. Yes, the pattern is repeating, but really it's mostly just that purple blue line and that green line, and yeah, there's a red in there somewhere hidden. You can kind of see it hiding back there. And that's it for mercury, even though it has so many electrons. And again, if we see this pattern from another light source, we can say that the light source probably has some mercury in it. All right, one more example for fun. So this is neon, and you may have heard of neon signs where neon gas is put into that glass tube and electricity is turned on and the neon sign lights up. And you can coat those neon bulbs with other materials to give you other different colors, but this is neon, a pure light source. And when I want to look at its line spectrum, I put the lens over, and you will know it is just a bunch of lines, and you can see a lot of the reds and yellows, and they're very close together, and it's very complicated. And this screen actually isn't doing it justice to the amount of lines that's actually happening. This screen's actually muting quite a bit of it. But again, if we see patterns of this from an unknown light source, we can assume that light source somehow, some way has a good amount of a neon in it. Okay, so in summary, Niels Bohr, he used hydrogen. Hydrogen only has one electron, so it's the simplest atom to work with to learn about its electron, because it only has one, and its behavior. And he noticed that when that hydrogen gas was excited, that electron bounced around, got excited, and when the energy was being used up by the electron, or the electron no longer wanted that energy, it went back down to what we call ground state. And when it did that, that electron had to give us back that energy in the form of light. And that light has very specific wavelengths and or frequencies of color. And it's those colors, those wavelengths, those frequencies that tell us that electron had very specific amounts of energy, because we get very specific colors, because we get very specific lines. This is called a line spectrum of an element. And one last thing, when you talk about multiple line spectrum, plural, there are line spectra. So line spectra is the plural of line spectrum. But I hope you had some fun with this. Thanks.